Hello, welcome, and thank you for virtually attending our presentation today entitled Backlighting and Challenging Applications. I'm Daryl Martin, Technical Sales and Product Specialist for Advanced Illumination. My current job duties include technical support and assistance for our channel partners such as OEM Automatic. First, let's acquaint you a little bit with Advanced Illumination. We opened in 1993 as one of the first LED lighting companies for machine vision. We're a full line lighting solution company, and that includes both lighting and controllers that are designed to work together. We really invented Vision Strobe Overdrive. Our product line is very scalable. We have over 500,000 built-to-order combinations available anywhere from 1 to 3 weeks at receipt of order. We also work semi-custom and custom products available, and we sometimes will start with our large BTO library. I've experienced technical staff in both pre and post sales. A lot of lab and loaner services are also available, particularly through our channel partners. And we do extensively collaborate with a lot of leading machine vision manufacturers. So today, the webinar topics I want to discuss are kind of the objective of vision lighting and contrast, the review of light, backlighting geometry specifically. We'll then talk about the UltraSeal IP69K certified backlights. We'll talk about how they might be deployed in particular applications, and also challenges and benefits involved with those particular deployments and applications. And I'll talk a little bit at the end about future directions. So what is the primary objective of machine vision lighting? What we really want to do is control the lighting environment. And why do we want to do that? Well, we want to create feature appropriate lighting on your particular parts or objects of interest. And we want to standardize on components, techniques, deployment, and operation. We also want to generate reproducible and robust results from all types of variations. So, having emphasized feature appropriate lighting contrast, it really is all about creating contrast. And as you can see here, the yellow print against the white background, poor contrast, versus the red against the white background, very good contrast. But there are basically two rules of thumb we want to consider. And we obviously want to maximize contrast on the features of interest versus the background. The other rule of thumb is we want to try to minimize the sensitivity to normal variations. And this could be minor differences in the parts themselves, presence of or change in the ambient lighting or some other factor, external factor. Sample part handling, presentation differences also can play a major role. So if we look at this demonstration image here, we have two nylon impregnated nuts. As you can see, the one on the right probably has nylon in it. The one on the left perhaps doesn't. Certainly our eyes can pick this out, but your vision camera may struggle. And as obviously we haven't really created much in the way of contrast between the feature of interest, which in this case is indeed the nylon. So how do we change that? Well, the obvious solution in this situation was that knowing that when you fluoresce the nylon with UV light, it tends to emit a blue wavelength. And so it's easy to isolate that wavelength using a pass filter. And so the bottom line is then by just simply adding this pass filter into the optical path, we change the contrast remarkably. So you want to remember that although point 1 may solve some applications, you want to always keep in mind number 2 can be critical as well. So let's review a little bit about light very briefly for vision illumination. The takeaway from this slide really at the end of the day is that eyes and cameras see quite differently. And I can just sort of start by prefacing this to say that if we look at the entire electromagnetic spectrum, obviously humans are reading somewhere in the range of 400 nanometers over here on the short wavelength side, UV side, deep blue side, over to the near IR red side, which is red at 700 nanometers. But that's just one small piece of the overall electromagnetic spectrum, as you can see here. We also have UV, we have UVA, B, and C, much shorter wavelengths. We also have IR, which is also kind of subdivided into near IR, short wavelength, mid-range, and then long wavelength IR. So continue on about contrast. How do we change or create contrast? Well, there are several ways to do that. Primarily, I look at the 4 cornerstones of lighting. So the first one would be changing your light object or camera geometry. In other words, that's just that 3D spatial relationship between the light, the object, of course, and your camera. And you can see here, a little noisy, but you can see you've got a camera, an object, and then you've got a light that might be positioned at higher angle, could be positioned at lower angle. Same thing here, you've got a ring light where it may be a higher angle ring light, maybe lower angle dark field ring light. So that basically accomplishes what we would consider geometry. And then we also have changing the light pattern or the structure. And this can be equated mostly to a particular type of light that you are projecting light onto, which may be a spotlight, it may be a line light, it could be a dome or some sort of array light. Or it's also involved with an illumination type. Now, obviously today we're going to talk about backlighting more than anything else, concentrate on that. But however, there are diffuse lighting, as I mentioned, dark field and bright field lighting types, and all those are involved with, as well as the type of light involved with the change in your light pattern. Another way to do it, of course, is to change the spectrum. In other words, we might look at monochrome versus white on objects for camera response. We may compare the warm versus the cool color families, as you can see here. Red versus green changes the contrast pattern on colors rather dramatically versus their backgrounds. And then finally, the 4th lighting cornerstone is we change the light character. In other words, how do we filter or affect the wavelength or the vibrational direction of the light to the camera? However, what's important though, especially the last 2 cases, is you want to keep in mind the impact that the light has on the part as well as immediate background. So if we look more specifically at backlighting, I just want to contrast the 2 different styles. Obviously, this would be a typical standard sort of front lighting application with a coaxial light. Basically, the light is projected out of the light head itself onto a beam splitter, 50-50 splitter, then down to the part, and then back through, in this case, to the camera. So that would be considered just a standard sort of front light. And obviously a backlight's a little different situation. You're creating your contrast here primarily. If it's an opaque object, you're creating that silhouette, instant high contrast silhouette, very bright on the around the backlight where there's no part, and then dimmer, of course, where there are no light at all where there's an object. And backlighting is beneficial for a lot of different applications as well. So edge, hole detection for one, part presence, absence, location, orientation. Useful, of course, on translucent or transparent materials as well. And of course, in this case, we may be looking at something like liquid fill level, glass or plastic defects. Longer light tends to penetrate objects better as well. We want to keep that in mind, longer wavelength light, I should say. Vision guided robotics, such as pick and place, backlighting can be used as well. Gauging, very important part of what backlighting is involved with. There's a subset of that called high accuracy gauging, and typically you want to use monochrome light. The shorter wavelengths tend to be better, which I won't get into that detail. Collimation prefers the parallel rays, and you can see an example of that right here where the rays are mostly parallel, whereas over here they're more diffuse and random in pattern. And the advantage here is that you get sharper edge detection with collimation. So here's a backlighting example. Let's say we were tasked with determining the fill level in a small bottle. Well, obviously in this case, it might be beneficial to make the assumption that your light will penetrate the bottle and allow you to see the liquid fill level inside. So we might start with our standard red 660 nanometer backlight. As you can see here, well, we didn't get any penetration at all. Everything's dark, so we've got a nice silhouette if we were trying to gauge. However, so we thought, well, let's try longer wavelength light, like 880 nanometer. This is IR, so the camera sees it quite well, but our human eyes don't in particular. So same situation. It didn't really help penetrate this glass at all. So now we thought, well, we went long, we went medium, let's go short wavelength. And sure enough, the short wavelength light penetrated this glass quite easily, and you very easily can see the meniscus here, so you can see the fill level. Now what's interesting is that this glass happens to be blue, which might sound like, well, there's an obvious choice, but you want to remember with transmitted light, the physics is a little bit different versus reflected light. So it just so happens that the glass itself tended to pass the blue light, and it wasn't really necessarily related to the color of the glass at all. It was very dark, but I knew when I held it up to sunlight I could see the fill level, so I knew there was some part of the spectrum in sunlight at least that was allowing this to pass. So sometimes you want to keep in mind some material properties as well. And here's another example where sometimes longer wavelengths tend to penetrate semi-transparent parts better, other times they do not, and this was a classic case where it was really a function of the material properties themselves. So I want to concentrate more a little bit specifically on the UltraSeal washdown backlight series. And this is based on our standard BL series backlit backlights. What I did want to emphasize is that these lights are IP69K certified, so they are designed for really extreme environments, and I think the important note or differentiator to make here is that they are indeed certified by an independent agency, so there's no question that they meet those standards. It's not a guess. They are crevice-free, compact, as you can see, so that's going to minimize any debris buildup on the surfaces. It makes it easier to clean them as well, more quickly. They are FDA compliant in the sense that we use a proprietary nickel phosphorus coating that's very even, and it improves corrosion protection considerably. In fact, it's less corrosive than stainless steel. The housings are also much more thermally conductive than stainless, which is a big advantage in an environment, especially a hot environment where you're always concerned with keeping heat away from the LEDs, because that is essentially how they are destroyed. We have multiple sizes that we stock as well. We can get larger sizes, other sizes I should say, with longer lead times as well. As you can see here, we've got multiple wavelengths available: blue, green, red, IR, and of course white. Obviously, if you're involved in a food contact application, it's probably best to talk with the folks at OEM Automatic UK, and then they can certainly confer with us if need be, and we can verify that whatever your specific conditions are, or sometimes your chemical conditions, environmental conditions might require us to have a closer look to be sure we feel we're comfortable in that sort of an application. So let's talk a little bit about where we're targeting these backlights specifically. And obviously high pressure washdown because of the IP69K rating is critical. We're also looking at chemical or caustic aseptic washdown capabilities. And in this case, certainly we might be considering direct food contact with high caustic solutions for cleaning and such, hygiene solutions that must sterilize, as well as the heat and high pressure. Obviously food and beverage or food contact, and high temperature environments as well. Dust environments is another big one. So if you can kind of contrast and compare our light with some of our competitors' lights out here as well, you can see quite a difference. Certainly a case like this would not be good for food contact applications because it's going to catch debris. Let's take a closer look at some of these challenging applications. First off, we have bottle inspection process, and specifically here we're involved with the backlight in cap presence and position. Clearly in this case, common cleaning solutions oftentimes will include caustic sodas and antibacterial detergents. These do increase the risk considerably of corrosion on the materials all around as well as the backlights. The benefit here, of course, is the proprietary nickel finish that we offer on this product. Very non-corrosive and certainly will protect against these caustic solutions. Secondly, food inspection. The challenges in this situation, particularly with backlighting, are of course sorting, typing, or quality control of the material themselves. And obviously a sterile environment requires that we don't have any sticky accumulation of food substances that might later fall back into the food stream. And the benefit in this case is, of course, the lights are crevice-free design and IP69K rated as well. So that allows easy cleaning and minimal time cleaning, which is a benefit for everyone. Thirdly, high temperature environments. In this particular instance, we might be inspecting or grading baked goods. And clearly, machine vision lights with poor thermal conductivity are going to have an issue dissipating the heat properly, which of course would shorten the lifespan considerably of the light head itself. Benefit here is that we use an aluminum housing, which is very thermally conductive compared with stainless steel, and then of course it is protected with the proprietary nickel process as well. So you're going to improve your thermal management considerably. We have another light in the family, and it will continue to expand as time goes on, but right now we have a bar light, UltraSeal AL247. Exact same process involved, an exact same sealing, IP69K rated. We've got 4 standard lengths available in this particular light. It's configurable in up to 11 different wavelengths. We did not offer UV in part because the material we have to use for the window tends to basically absorb the UV rather readily, so just not going to be available in that instance. If a customer runs into this situation, we can certainly research it deeper to see if we can find a window that would meet all the IP69K and necessary hygiene ratings, and then also would pass the UV. 3 different lens types available, so you're not stuck with a single focus when you order. Of course, that's at time of order, you make that selection. With some future expansion as well, so we do intend to work toward offering spotlights, perhaps ring lights. There's been discussion of a flat diffuse light, which is basically a backlight like this, except with a port in the middle to flip it over, use it as a front light instead. And also focused line lights for line scan applications, high-speed line scan applications. That presents a bit of a challenge because of the sealing and the thermal dissipation requirements, but we're working on that. Here are a few relevant company contacts here at Advanced Illumination. We do, of course, encourage you to contact the OEM folks when you have an application, and they can certainly confer with us for further help. And this concludes our presentation for today. We certainly hope this information was instructive, if not illuminating, and thank you so much for attending.